Another type of pavement is a rigid pavement with which have a high flexural rigidity and are able to transmit load into wider area. The pavement absorb the most stress, thus requiring minimum layers. So yung rigid, mas onti yung layers niya. Yung flexible kasi, mas maraming layers. Yung rigid pavement, thicker, mas makapal siya kumpara sa ating flexible pavement. And usually in the Philippines, rigid pavement tayo. And also, rigid pavement, either be doweled, may dowel tayo or tie bars, para hindi maghiwalay yung ating mga pavement. And na-allow nito yung transfer of load from one slab to another. So, yung mga roads pala natin and pavement, ang consideration natin yan, slab on fill. Okay, so a rigid pavement is constructed with usually cement, no? And aggregates. So, yan, meron tayong base, tapos meron tayo, ito na yung pavement natin, mas makapal yung pavement natin, and meron tayo usually na dowel. Kaya yung dowel, sobrang liit lang niya. Okay. So, una, without dowel. So, possible pala na yung mga daan talaga natin ay walang reinforcement. So, that is a rigid pavement without dowels or tie bars. The critical section at the edge of the construction joint, it will crack approximately 45 degrees. Okay. Dahil wala tayong reinforcement, kapag ka nag-split na o kaya gumalaw yung ating pavement, pag naghiwalay yan, ang direction is 45 degrees at the edge. So, mangyayari dyan, F is the allowable tensile stress of concrete in PSI. Yung W is yung load natin. Then, of course, the moment that we will create yung from the W, kung saan yung point of action, times the distance X, that is your moment. Then, para makuha natin yung flexural stress or tensile stress, that is 6 times the moment over BD squared. So, ito yung ating pavement, no? Ito yung load. So, yun yung ina-assume natin na parang triangle ni ulit. So, X and X is the base, which is 2X. And the thickness of your pavement, that is your depth. Okay, so dahil ito yung formula natin of flexure, yan, substitute lang natin yung mga values, and the thickness will be 3W over F, or the allowable tensile stress. Kapag with dowels naman tayo, mahati sa dalawa yung ating, or mayroon tayong dalawang consideration nga. Una, at the edge. Sa edge, yung mga edge, ito, edge, yan, yung mga edge yan. Edge. Mga edge, Wx over 2 yung moment natin. Pagka sa center, since apat yan na naghahati-hati sa kanya, divide by 4. So, yung thickness natin at the edge is, no, let me say, P is equal to 3W over 2F. Tapos, pagka at the center, over 4 siya. Kapag no dowel, wala din tayong over 2 dito. Okay, so let's have a sample problem. We have a sample problem. Determine the thickness of a rigid pavement of the proposed nagtahan road to carry a maximum wheel load of 60 kN. Consider with and without dowels. So, tensile stress o yung F natin is 0.06 of F prime of C. And this is equal to 0.06 of 20 megapascal. So, yung F natin is 0.06 times 20, that is 1.2. So, if that is 1.2, okay, if that is 1.2, now we can solve for your Determine with and without dowels. Pag with dowels daw, formula natin is thickness. Without muna pala tayo. Without. Thickness is equal to the square root of 3W over F. So what is our W? That is 60. Square root of 3 times 60 over, oh, sorry, this is 1.2 megapascals. 1.2 megapascals. But this is in kilonewton. Dapat yan naka-newton. So, gawin natin siyang 60,000. So, the thickness is 387.298 millimeter without dowels. So, pag pa with dowels, okay, with dowels tayo. Okay, with dowels. At the edge, that is, your thickness is equal to the square root of W over 3W over 2F. Okay, so as you can see, the result would be 273.861. And sige, solve mo muna natin yung at the center. At the center, that is square root of 3W over 4F naman. So that is 3 times 60,000 over 4 times 1.2. And T is equal to 193.649 millimeters. Okay, so ano yung mga significance ng value na yan? As you can see, pag wala tayong reinforcement, mas makapal dapat yung pavement natin kasi mas malaking tendency na maghiwalay yung ating, since kasi diba, for example, ating connection ng pavements natin. Diba putol-putol yung daan natin? Hindi siya naman buong daan, sementado. Meron siyang mga division. Ito kunyaring division. Kapag lagi ang nadadaanan, nagkakaroon lagi ng load, ang tendency, since lugtungan to, lagi doon yung problema natin. Maghihiwalay at maghihiwalay yan. Pero, since naglagay tayo ng reinforcement, malilesen yung tendency na yun. So, dapat, pag naglagay tayo ng reinforcement, mas mababa na yung kailangan nating thickness, which is na-prove naman natin. So, definitely, dahil apat yun, yung nagsusupport sa center, mas mababa yun. Pero hindi tayo nagko-construct ng daan na mababa to. Usually, mas mataas yung thickness ng nasa center for drainage purposes. Okay. So, of course, if we need a dowel, we need to know what is the spacing of our dowels. So, we have a concrete pavement 8 meters wide and 15 millimeters length, which is to be provided with a center longitudinal joint of 12 mm diameter bars. The weight of the concrete is 2,400 kg per cubic meter. Yung coefficient of friction is 2, and assume an allowable working stress in tension is 100. The steel bar is 138 megapascal. So now determine the spacing of the longitudinal bars. So how are we going to do that? So for the spacing ng longitudinal bars natin, ito ang ginagawa natin. Di ba meron tayong bar? Or for example, this is our pavement. Actually, supposedly, dalawang magkahiwalay na pavement. Yan. Maglalagay tayo ng mga reinforcement dito para hindi sila maghiwalay. Pag naglagay tayo ng reinforcement dyan, spacing yung nahanap natin, no? Yung spacing, ito yung distance between two reinforcement or pwede rin naman center to center distance ng mga reinforcement natin. So that is also spacing. So, kinuha natin yung area. Yan. Yan, yung area niyan. Para makuha natin yung load ng bawat, i-carry ng bawat reinforcement. So, we have the, what do you call that? The weight of your concrete, 2,400 kilogram per cubic meter. So, dapat Newton sa'yo or megapascal, multiply natin sa gravity para maging Newton yung kilogram. Then, multiply natin siya dito sa area. Sa area nito. So, meron tayong sa area niyan, if meron, or volume, para makuha natin yung weight, yung point load na kailangan natin. So, volume, dapat yan yung S. Yung thickness natin, sabi is, ang thickness ng pavement natin is 150. Then sabi niya, yung road daw natin is 8 meters. E dalawang pinagtugtungan. Kaya dapat isa lang yung kukunin natin. Ito lang, which is 4 meters. Kasi parehong 4 yan. So the W or the weight is 14,126.4 multiplied sa S. Unknown kasi ito sa atin, wala pa tayo isang equation. So, meron tayong pwedeng gamitin na equation which is in tension, which given yung tension force, yung tension stress natin, multiplied sa area. Okay, so yung tension force natin, yung tension stress is 138, tama ba? 138 megapascals multiplied sa multiply natin sa kanyang area ng 1 bar. That is pi over 4, 12 squared. Okay, that is your tension is equal to 15,600 Newton. Okay, so now, yung normal load, kasi di ba meron tayong pavement dito, no? Yan, for example, yan yung piece nito. Ito yung piece na to. Ito, ang large niya, ayan. Yan. Ang thickness natin is 150. Ngayon, weight is, ito yung weight natin, 141. Then, yung normal is yung against sa kanya. Then, in tension forces natin. Okay. Yung normal should be, normal stress is, supposedly, it is equal to your, dapat equal yan sa inyong normal. Kasi summation of forces horizontal, it should be in equilibrium. Okay, how about naman yung force affected by a friction? So meron tayo mu, yung mu natin multiplied dapat siya sa n. Para makuha natin mu n, that is a force affected by a friction. So yung ating friction is given tayo ng mu or friction coefficient, that is 2.0. Coefficient of friction at the subgrade. 2.0 times yung sa weight natin, kasi yun din yung normal force natin, 126.4 S. So, yung friction force natin is equal to 28,252.8 S. So, ngayon, tensile force, kasi iyan yung force of friction, no? Yan yung resisting force niya. So, dapat in equilibrium, para equilibrium, equal yan. So, that is 28,252.8 S This is 52, which is equal to your tensile force. That is, your tensile force is equal to 100, 15,600 Newton. And that would give an S. So 15,600 Newton divided by 28,252.8. And that is equal to 0.552, or an spacing of 552 millimeter. So basically, hindi naman pwede na may 2 pa tayo. It could i-round up na natin. 0.55 or 0.560 para wala tayong butal. Okay, we have another. Okay, of course, syempre, if we know the spacing, we shall know the length. Ano ba yung length dapat ng bars natin? So we will use a 12 millimeter diameter bar, longitudinal, of a concrete pavement. Yung spacing niya on centers is 600 millimeter. And the width ng roadway and the coefficient, the width of the roadway, sorry, okay, yung width of the roadway and coefficient of slump is 2.0 pa rin, and yung thickness is 150. So what is the allowable band stress? Okay, so ganun pa rin naman yung gagawin natin, kagaya ng ginawa natin kanina. So meron tayong 0.6 na spacing lang kasi, no? So kunin natin yung weight. Again, meron tayong figure na ganito. Pabalik na rin naman natin. So, kung natin yung weight, normal force, tension, and friction. So, sa normal weight, that is your 24,000 kilogram per cubic meter weight of the concrete times the volume. What is the height? Height natin is 150 pa din. And yung spacing natin is, sinabi naman, 600. And then, we also have yung width ng road natin. Sige, let's say na lang that the width of our load is 4 meter as well. W is 24 times, multiply pala natin ito sa gravity, sa 9.81. Kasi, para mapakabasa ko siya. 24 times 9.81 multiplied to 600 times 150 times 4 meters. Or, I'm sorry, so this should be 0.15 kasi 150 millimeters yan. Then 600 millimeters should be 0.6. And that would give us a weight of 8,475.84. That is in Newton. So this is also equal to the normal force, and then friction force, which is equal to mu n. Yung mu natin is 2 pa din. So multiplied by 2 natin to, which is 16,951.68. And tension force is equal to the friction force. And yung ating tension force is equal to, okay, tension force natin, sabi natin kanina, equal to dapat sa ating stress times the area. So, meron tayo 0.83 stress per bar. Tapos yung area natin is pi, or kasi ang sabi band stress, no? Band stress ang binigay. So, ang skin area to. Skin, yung paligid ng bar natin. So, band stress ang binigay. So, ang stress na to is between this. So yung circumference, which is pi d of our diameter times the length of your bar. So that is 0.83 pi. The diameter of our bar is 12 and the length, then it is equal to 16,951.68, which is L is equal to 541.756. Okay. Pero yung area na to, yung ito lang, kasi ang kinonsider lang natin ito yung kalahati ng ating pavement. So, hindi naman pwede na, kung ito yung road natin, ito yung buong reinforcement, hindi pwede magkahati lang sila. Dapat buo. So, dapat times 2 natin to. And that is equal to 1,083.512. So, let's say that is 1,100 millimeters or 1 meter and 1.1 meter. So, imagine, maliliit lang talaga yung dowels na ginagamit natin. Hindi tayo gumagamit na para tayo nag-slab na 300 millimeter lang yung pagitan. Hindi. So, gumagamit lang tayo ng dowels. So, that's it.